Just a couple of words about reliability analysis. Why do I mention it here? Well, for a very simple reason. Because when we do exploratory factor analysis and confirmatory factor analysis, we typically try to develop a questionnaire. First, we try to find out what dimensions are there in my items. Next, I test whether these dimensions really explain the variance in my items. And after we conduct exploratory and confirmatory factor analysis, we want to estimate the internal consistency of our future scales. And we can use here either Cronbach's alpha, good old Cronbach's alpha that is available in SPSS that maybe you have all tried already at some point. I will just remind you that Cronbach's alpha makes some unrealistic assumptions about our data. For example, it assumes that all my questions measure my latent construct equally well. Essentially, they have equal error variances or equal factor loadings, which is of course not the case. So Cronbach's alpha will reflect the reliability of a simple sum of answers, where the good and the bad items make equal contribution. But of course, in reality, our factor model shows us that factor loadings are all different, and maybe we need some more tricky reliability coefficient to reflect this fact. And also Cronbach's alpha, when it's based on correlation, it assumes continuous normally distributed items. So essentially, what happens when these assumptions are violated? Most often, alpha is underestimated. So if your items have very different factor loadings, your alpha will be low. Or if your items are categorical, your alpha will be underestimated again. But if your distributions are not normal, or your item errors are correlated, you will get a slight overestimation of your alpha. That's why we might need sometimes other reliability coefficients. So one reliability coefficient that is very useful is available in R. It's called greater lower bound, or GLB reliability. And there were simulation studies that have shown that it works better for items with asymmetrical distributions, which very often happens with categorical items like Likert scales. So GLB might be higher than Cronbach's alpha. So as long as your sample is not very small, as long as it's about 100 individuals or more, you can safely use GLB, and you can argue that your reliability is actually higher than what Cronbach's alpha shows. And another reliability coefficient, which is model-based, it's based on assumption about the structure of relationships, is called McDonald's omega. And it can be calculated based on the results of a confirmatory factor analysis. The formula is fairly simple. You just take your standardized factor loadings, you sum them up, you square them here in the numerator, and in the denominator you add the same thing and the sum of item residuals, also standardized. And as a result, you get omega, which might also be more precise than alpha. It might be higher or lower. Usually it's higher, but it's definitely more precise. And it can even accommodate residual covariances if you introduce them into the model. You need to add them here in this denominator and multiply by 2. And as a result, we can get a better estimation of reliability based on our model. For very complicated models like bifactor model, there are different types of this omega which separate, for example, the variance that is general, the variance that is only shared by specific items belonging to a specific factor, with contribution or without contribution of this general factor. But these are all details. If you just want to compute a simple McDonald's omega, it's available also in Chamovi. Just tap this McDonald's omega in reliability analysis and you will get a nice estimate. Well, here they are pretty much the same because as we have seen, the item factor loadings are similar And also the distributions of these items are fairly normal, so it's a nice type of data. But sometimes you might see differences between the two. And another nice perk of Jamovi is that here there is this dialog reverse scaled items, and you don't really need to flip around all your reverse scored questions. You can just indicate here that they are reverse scored, and Jamovi will do it on the fly for you, which I think is absolutely brilliant. And of course, you can basically take the output from a confirmatory factor analysis and calculate omega by hand in Excel. This is also an option. So you have conducted exploratory and confirmatory factor analysis. You have evaluated your reliability. Now let's take a look at some more complicated situations.